Hello everyone, I am Biplab from IIT Guwahati. I am the instructor of your course Data Analysis for Biologists. I welcome you all to this live session. So hope you people can hear me and listen me. Please, if you cannot hear or listen, please raise your hand here in the team session, or you can put a note in the chat in the YouTube chat box. So let us know that if you have any trouble in audio or video. So as you know, this is an 8-week course, and in this 8-week course, we have almost 8 broad area we will discuss. So what I will do, the way we should proceed today's live session, it is a 1-hour live session. So what I will do, I will first discuss certain logistical issues that we have to keep in mind, because I'm meeting you for the first time. So some of the logistical issues we will discuss. And then what I will do is that I'll go through the week 1's content, week 2's content, week 3's content, and I will focus on those points, those key concepts where you should put thrust on, right? Not just for learning, also for preparing for the final exam and the assignment. And then we will also take up questions if you have any queries about any particular problem. In general, if you want to know something about this course, we will discuss all these. In general, in between, if you face any question, any query you have, please raise this here in the YouTube or in the if you are available through, if you have joined us through this Teams Teams app, then please raise your hand. You can will make you audible, and then you can also put up the question. Right? Give me a minute. Let me set this YouTube chat window a bit better so that I can see all of you. Okay. Narendra, Soil Vasa, Inamul Haq, welcome. I welcome you all. Okay. And we have some of the Amandeep and others are here. So I welcome you all again to this session. So as you know that we have already crossed the 3rd week, right? We already have the 4th week content has been released today. And I hope you people have already submitted the assignment for week 1 and week 2. So in week 1 and week 2, I hope you can see my whiteboard where things are written. If you cannot see my whiteboard, please let me know. So in week 1, we discussed about the basic concept of some statistics, probability theory and statistics. So remember one thing, as I have said in the course itself, is that this is not a biostatistics course. But without knowing some amount of probability theory, you cannot learn statistical learning. You cannot understand linear regression, polynomial regression, or reduction in dimension of data. All these things we will learn in the subsequent week. You cannot learn or appreciate unless until you understand the basic concept, key concepts of probability theory. So what we have done in this week, we have just superficially skimmed through the bare minimum thing that you should know in probability theory if you want to jumpstart understanding machine learning and statistical learning, right? So I hope you could follow those. Some of the topics you may find bit difficult, but don't get, allow that difficulty to overwhelm you. Keep persisting, keep trying, ask questions, ask your friends, put up questions here in the sessions or in the discussion forum. If you are shy to ask a question publicly, don't hesitate. You know my email ID. Drop an email to me. If you want that, you do not want to talk about your problems that you are facing, you do not want to talk that in public, you can always write me. And believe me, I try to answer each of these. May not be immediately within half an hour, but within a day or two, I always respond to all these emails, right? So don't allow any difficulty to overwhelm you and leave this course in between. Every time we try to learn something, there will be something unknown. There will be always something unknown. So you have to try to overcome that problem. Ask people, take their help. So we are here. I am, my TAs, all are here to help you, right? There is already a question from Anusha Bhatt. I joined the course late. I shall revisit the week 3 courses and submit the assignment. See, the issue is some people may join late. Some people may have busy schedules. Some people may have exams, other assignments, other commitments. This will be there. We all understand it, right? But what I will insist, whatever possible, take out some time, submit the assignment in time. Even in the last moment, submit it. You may not answer all those 10 questions in assignment. Try to submit whatever you can answer, but submit it, right? So you will see slowly you will progress and you'll make up that. Maybe in one assignment you will do bad, but the next assignment you will do good. And eventually, who know, you may do very well in the final examination. So no, sir, don't keep on submitting within the assignment within the deadlines. So if I come back to the course, you see the second week we have discussed some basic concept of linear algebra. I understand many of you may not have come from mathematics background in their undergraduate or level. They may find linear algebra a bit difficult to start with. But remember, the amount of linear algebra we have covered in this 5 weeks is elementary one. And just like probability theory, this elementary linear algebra is essential for statistical learning and machine learning thing. Otherwise, it may become very difficult for you to handle data, rearrange the data, and do the operations on those data, apart from understanding what is meant by those methods, right? So please try to understand those basic concepts. I will discuss key points which you should focus on, but please follow that. And the second thing is that the last thing in the last third week's content we have R. So this course has been developed around R, right? So this course has been developed considering that you will use learn R and use R packages and all these things. As you know, R is almost a academic and industry standard in data analysis and statistics, although some people may prefer Python or some other languages, but R is almost like a gold standard. So I will insist, please learn R. I know R has a bit steep learning curve, particularly if you never have done any programming or coding. It may seem very daunting task, but please don't get scared. Look into the codes of week 3. Step by step, follow them, and I'm sure you will learn to use R, right? So I'll come back to that, how to use those code and all these things, but this is what we have gathered in these first 3 weeks, right? Somebody has asked, will the final exam be in filling gap formats or MCQ? I'll come back and discuss about the final exam thing. And here in the Teams, there is a chat questions. Let me take that. I think there are many information that I do not think is important to us for biologists. For me, I thought there will be such learning SPSS and other data analysis applications. Okay, there are 2 things. First thing is that if you believe that you will learn only to press switches and the result will come, then actually you are fooling yourself, because if you do not know how a particular tool works, then the most probably you will fall in trap of misusing it. I'll give a classic example on which there are lots of paper in biology journal making biologists aware about the problem of misuse of t-test. T-test is a statistical test, and in our week 1 course we have that. And it's very easy to perform. Even in Excel sheet, you can do that, right? So what has happened over the years, you will see biologists tend to use t-test like anywhere. Almost everywhere they had to do it without understanding the basics of t-test. And so they cannot comprehend what is the limitation of t-test, when you should do, when you should not do, right? Even when you are doing t-test in R, if you see our video on t-test using R, you will see there are ifs and buts that you have to keep in mind and use it. Now, what happens if you use a software which will do t-test? It will just do the t-test and give you an answer. It will give an answer. Now, you may be happy with that answer because that answer tells you that your hypothesis is correct, so you are happy. But maybe you have used t-test in a wrong place. This is very common that when you are supposed to use one-way ANOVA, people use t-test because it pairwise t-test, and it is absolutely wrong. So that's what the crux is. If you do not understand the basic principles, then you will fall in that trap of misusing any particular tool, right? So we have to understand that we are not programmers who will develop programs and code, but that does not mean I should not understand the basic principle of those codes. I'll give a biology example once again to make this message clear. See, if you say that I know how to isolate plasmid, I have isolated plasmid using a kit. But if I say I know how to isolate the plasmid using a kit, but I do not know the principle, I do not know what is a plasmid is and what it is for, then it's meaningless. So I become a technician who can use that kit to isolate the plasmid, but I cannot understand why we are doing it, what is the purpose, and how the kit is working, where is the limitation, where I can use that kit, where I cannot use that kit, right? Or can I use that plasmid isolation kit to isolate genomic DNA? If I know the principle of DNA isolation, I should be able to manipulate that kit to isolate my genomic DNA also. So that is why you have to understand the principle of plasmid isolation using a particular process. The same thing is here. If you are learning linear regression, you have to learn the principle of linear regression. Otherwise, you will be working like a technician and you will misuse it. I believe biologists are not technicians, biologists are scientists, so we also have to learn it, right? So I hope I could hammer the message that why we have to do the hard work and learn it. Okay, now is there any other question that I should take immediately? Okay. Bhasa is saying, sir, I did not submit 1 2-week assignment, but completed the assignment. Bhasa, you cannot go back and submit. Complete the rest of the assignment in time, because remember, eventually if you go to the course page, there is a clear instruction given that how we calculate the final score. In that case, some best marks are calculated, taken from the assignments, and that get added with the final exam scores, right? So you cannot go back and correct what you have done, miss, but you can now perform better and make up for that. Hope it is clear to you, right? Okay, so okay, there is a question that, sir, is the knowledge of biostatistics essential here in this course or not? See, remember, this is not a biostatistics course. First of all, let it be clear. This is not a biostatistics course. But you are supposed to know biostatistics if you want to be a biologist. You cannot, say that I will hire a biostatistician, I will collaborate with a biostatistician, everything is fine. But you have to know the bare minimum thing of biostatistics so that you can understand what a statistician is saying, so that you can communicate and make them understand your problem and your issues, right? So there are biostatistics course in NPTEL, please do that. This course is what we call statistical learning or machine learning based course. So this is a data analysis course mostly. So you do not need biostatistics as an essential thing here, right? Okay, before I go forward, this is a connected issue. See, remember, do I need to read books? Some people ask, right? Do I need to consult some other videos, other lectures, some other things? Please don't get confused and get overwhelmed with the material available on the web or something. If you are an advanced learner, you can dig into textbook. There are very good online textbook available in the course page. In the reference section, you'll find some of them. You can go there if you are an advanced learner. Otherwise, if you are starting with baby step, don't get confused. Don't try to gather things here and there. Simply follow the videos. Follow the PDF file of each of the slides that we have uploaded along with the video. Follow the codes, practice them. These are good enough for this course. And believe me, if you follow them, you will not only pass the exam, but you will also have learned the basics of this and you will get confident enough to do complicated and advanced courses or learn advanced. Fine. So stick to the videos that we are showing. Stick to the the PDF file of each of the slides are provided. Read through them, check them. If you don't understand, ask questions to us, drop questions to us. That will be enough. Fine. Okay, so let me now go to some other logistic issue before we move forward. So if you know that we have live sessions, right? We have Pallavi with us, who is a PMRF TA, and she is taking 8 live sessions. And here I have shown the schedule. You may have, if you have joined her last live session, which was on the 4th, She has shown that. Now, if you have missed this live session with Pallavi, that recording of that is provided in the course page. Go to the week 2's contents and you will find an extra tab where you will find this recording of that live session is given. So please go through that if you have missed that live session. Why I am saying? Because in these sessions, what Pallavi is doing, she is going through assignment problems. She is going through extra problem that I have provided her to practice. So she will solve each of those problem individually. You can ask questions, you can clear your doubts there, right? So these are problem solving sessions and they are very useful. We have seen repeatedly that the students who join them, they find it very useful. So please take out the time. The next one will be on 13th, Monday, right? It will be from 6 to 8 p.m. So she will discuss obviously this third week's content. She will go through some extra questions that I have provided to her. She will discuss those. You can ask questions. Obviously, she will not tell the answer of the assignment, which is still pending. But remember, if you join this may help you to answer some of the questions of the third week assignment, which you may find difficult to do, right? So please join it. We always send the link and all these things in the announcement. You have the Zoom link given, and you can see the recordings also in YouTube if you go through this link. So I'll keep this for 1 or 2 minutes. So if you want to note down, you can note down the link. Otherwise, the link and everything are provided in the announcement page. In the discussion forum, I have a post, and there is a separate tab in the second week where you can go and get the links also, right? Okay, so if this is fine with you, if you do not have any query, let me go to some other very important logistic issue. The first thing, please learn R. Just learning some theory, some ideas, some methods here will not help you to execute them unless until you do it yourself, right? R is a higher level language where you have all those functions available by which you can execute. You can do statistical analysis, data analysis, statistical learning from data. All that we will learn in this course can be done very nicely using R, including data visualization. I have seen many biology students, they create visualization graph and plots using Excel. Remember, Excel is not for scientific plotting. Some of the lab may be rich, they may have dedicated tools like Sigma plot or something, which you can make professional looking graphs, but everybody may not have it. R is free and R has very powerful data visualization tool. Particularly one is called ggplot2, which I will teach in 2 videos in the coming week. In the fourth week, you have a video for that, right? So you should learn that at least for data visualization. Then you can actually make very beautiful, high quality publication grade graphs and plots and for visualization, right? So please learn R. Somebody has asked earlier a question, posted a question to me by mail that whether there will be R-based questions in the final exam or not. Remember, the final exam, as somebody asked what type of question will be there, the final exam will be like GATE or JEE. It's a machine-based exam, right? You will go to a center where there will be a computer and you will have the questions. It will be MCQ short answer type, the way we are asking questions in the assignments, right? In the assignment, see, we have not asked you to write R code. You are not running any R code in assignment. The same thing is in the final exam also. You will not run R codes, but there will be R-based questions. You may have seen the assignment in the third week, we have R-based question. For example, I may give you an R script and I may ask, tell me what will be the final answer of this script, right? And this can be in an MCQ format, in multiple choice format, or also if it's a numerical value, you may have to enter the numerical value, right? So these type of questions will be there. You will not write a code and run an R code, but there will be R-based problem. Now, each of the say week from starting from third week, we have R-based lectures. So the codes of each of these lectures you can get 2 ways. One, If you go to the course portal, just below the video, there is some content. In that content, you can either download the PDF file of the slides, or you can download a zip file which has the code and the data used in that particular lecture. So you can download them. Or what you can do, you can go to my personal GitHub thing, GitHub Biplab Bose. Biplab Bose is my user, right? So you can go there, and this data analysis for biologists, this repository is public, so you should be able to download it. If you are finding difficult to find this link, you go to the discussion forum. I have posted a message there where this link is provided, right? So download them, use them, practice them. The best way to learn programming, if you have not done programming before, is that you simply edit it. You delete this part, delete that part, change something, see what is happening, what error message is throwing. Is it calculating something wrong? That's the way you should learn how to write the code, right? That is the easiest way to learn. So take this code, edit them, manipulate them, and learn. Fine. Then another very common question about exam, about calculators. Okay. As you know, just like in GATE and JEE exam, you will not be able to carry any calculator, physical calculator. They will provide an online calculator. You can find a search in the web like TCS iron calculator. You will see the scientific calculator that they provide. So you will use that online tool they will provide in the exam hall itself, right? Now, suppose there are some matrix multiplication, determinant of a matrix to be calculated, or the length of a vector has to be calculated, all these things. So then what you should do, right? Those scientific calculator will not allow you to do. Yes. When you are learning, I will say you can use online tools to do this vector calculation, but please practice doing this by hand, paper and pen. For 2x2 system, 2x2 matrix or a vector with 3 element or 2 element, these calculations are pure simple arithmetic, nothing more than that. School level arithmetic, multiplication, division, addition, subtraction, right? You should be able to do that. For example, determinant for a 2x2 system is very easy to do. You just multiply the diagonal element and subtract from each other, right? So those formulas are seen. You can see that in the video, in the slides, right? So practice them to do it. Those are doable. So you do not expect that there will be a very complicated question, which is a very long, lengthy calculation that will be given you in the exam. No. In the exam, something will be given which is doable by paper and pen using the standard scientific calculator in a reasonable time. We will not give you a question that will take you half an hour to calculate the matrix algebra. No, we will not give you. We'll give you simple questions which will test your ability to do that, and we understand that you have understood the concept, right? So simple calculations you have to do. You will get that scientific calculator, but please practice them. Please practice them as we are going through different lectures. Fine. Okay. Up to this, I have discussed the logistical issues and the gross overall the idea about the course and what you should do, what you should not do. If you have any query about the exam, assignment, and all these things, please ask here. Otherwise, I'll move into the key points which you should highlight and learn specifically for week 1, week 2, and week 3. If you have any question, please you may ask now. Okay, I do not see any query right now in the neither here in the Teams, neither in the YouTube. If I have missed your question, you can please post it again, right? So I'll try to answer. So let me go to week by's key point that you should highlight. The first thing is basic rule of probability. What do I mean by basic rule of probability? Simple thing, right? For example, that summation of probabilities all will be sum equal to 1. Probability of an event cannot be greater than 1, less than 0, right? So something like this, these basic rules of probability that we have to keep in mind, we have to learn. Addition, multiplication rule of probability. This is essential. Any data analysis, unless you understand the difference between exclusive and independent event, you may fall in trap. very easily. It is very important as you do large number of data analysis, right? You have to understand which of the things are mutually exclusive, which of the parameters that you are measuring are mutually exclusive, whether they are independent random variables or not. That you have to understand, right? So please go through this issue of mutually exclusive and independent events and how the addition and multiplication rule play for these mutually exclusive and independent events. Another important thing to understand the difference between PMF and PDF, right? So, the PMF and PDF, sometimes I see people are confused. So remember, PMF is for discrete random variable, right? For example, you are counting how many people are there, discrete number. You cannot have 1.2 people, right? So in that case, if you are measuring probability, you have probability mass function, and that function gives you the probability. Whereas PDF you have to understand in the video I have explained is PDF is for continuous random variable. You are measuring blood pressure. It's a continuous random variable. And in case of continuous random variable, you cannot ask a question like, tell me what is the probability that the person's blood pressure will be 120. No, you cannot ask that type of specific question. You can ask the probability that what is the probability of the person will have a blood pressure between 121 to 122 in a range. So in that case, PDF is a function which is used to calculate that, right? So this difference you have to understand. PDF is not a probability, it is a function which we use to calculate the probability. Then some PDF and PMF which we have given, which are bread and butter of any data analysis and statistical learning, is binomial, multinomial, and Poisson. Please check the equations, the formulas. They are not so difficult to remember. If you have studied math in class 12, you will easily remember them because you must have studied them then, right? And you should be able to use that formula to calculate simple probability. Again, I will say, we will not give you a very lengthy, complicated calculation in an exam. All calculations should be simple, but you should be able to use this formula how to calculate them. The same thing is for normal, standard normal, uniform, and exponential distribution. Particularly, the standard normal distribution, I have seen people get confused. So you should know that standard normal distribution is nothing but a normal distribution with mean 0, standard deviation or variance equal to 1, right? So again, these equations are bread and butter of any data analysis, And understanding normal distribution is key to what you call biostatistics. Without that, you are a lame. You cannot move forward, right? So again, in this case, look into the formulas given, the parameters, right? If I change the parameter, how they will behave. Don't go into complicated problem. How, if you simply change one parameter, if I change the variance, how the distribution will look like, right? So these type of things you try. Second thing is the idea of mean, variance, and moment, the formulas and how we are getting it, right? And you should know how to calculate the mean and variance from data, particularly variance and covariance using this Bessel's correction. This is a common mistake I have seen in assignment and examination. Not only that, I have seen students, PhD students doing this wrong calculation even in their lab. Many people use Microsoft Excel to calculate mean and variance. Even in Microsoft Excel, there are two types of variance calculation. One is using Bessel's correction, one is without. Most student does not know, and they need to calculate without any corrections, right? So as I have discussed in the lecture, for a small sample size, if you do not use that correction, you are not calculating the right variance. Your variance is biased. That's not a right estimate. It may not matter for you for the time point. It may match with this is very happy, but remember, you are doing a wrong calculation, you are doing wrong science, right? So learn how to do it, the calculation. And again, in this case, I will say, please practice by paper and pen. I will not give you, a large 100 data points to calculate covariance or variance. But you should be able to do the calculation if there's 4 data points, 5 data points, 3 data points, right? And the calculation with the corrections. Another important thing that you have to understand, if you want to do experimental biology throughout your life, the meaning of covariance, and later on we'll learn also correlations, right? These will come up very frequently, particularly as we are moving into high throughput data of genomics and proteomics, large scale data are generated. and we try to find the correlation and covariance between different variables, different measurements, right? We need to understand what is the meaning of covariance, what is the meaning of negative value, positive value, zero, what is the problem of linearity and non-linearity in covariance. All these things are discussed in the videos. If you have any problem, any time going through that, please post a question, or you can ask the question here itself. Another important thing, many a time when we do experiment in lab, particularly if you are doing experiment using animal model, you will find your data in contingency table format. You will find the contingency table in my video and lecture on Bayesian estimation, Bayes theorem, right? So in that there we start with a contingency table. And if you are doing any animal experiment, or you have multiple crossbreed of transgenic plants, you are doing different stress response and all these things, you may generate data in a contingency table format. And in that case, you have to calculate all these things. For example, conditional probability, joint probability, marginal probability from the data, right? So it's very easy to do the calculations. In that video, we have done the calculations repeatedly. Please go through them and understand them. You need to know the Bayes theorem. You cannot avoid it. Modern science, modern biology, modern biostatistics also is becoming Bayesian, right? So the essence of Bayesian analysis you have to understand. For that, you have to understand what is Bayes theorem, that simple theorem that we have discussed, and it connects you to the problem of specificity and sensitivity. In the Bayes lecture, I have discussed about sensitivity, specificity for a diagnostic test. We'll come back to sensitivity and specificity again when we will do classification problem. Classification problem, like suppose you have gene expression data based on which you want to classify a tumor sample between benign, right, or cancerous. Fine. So in that classification problem, you create classifiers, a mathematical model. Okay, so that will help you to classify. So when you create a classifier, again you have to test. It's just like a diagnostic test. It's just like a ELISA test, but mathematical ELISA, I can say, right? So again, you have to use the concept of sensitivity and specificity. And many a time, even seasoned scientists mix up what is sensitivity and specificity. So please go through the definition, and it should be in your, get embedded in your brain. You should not get confused with what is sensitivity and specificity forever, not just for this course. In future, whenever you will have this experimental thing where you will develop experimental method, classifier or something, you will encounter sensitivity and specificity issues, right? Then the concept of null hypothesis, though this is not a biostatistics course, I have given one video. So you don't need to go into detail of statistical tests of ANOVA and all these things. Just superficially, I have discussed it so that you get a flavor. You can, if you have done the courses, things can get, recapitulate. Another reason of doing this, because this null hypothesis test, you don't only do for your experimental thing. When we will create this linear model, nonlinear model, we have to do this type of statistical test for that model also, right? So in that case, we have to do ANOVA type thing. So I thought of having this lecture so that you can easily understand at least why we are doing those. Fine. So these are the key elements that you have to focus in week 1. I do not know whether you have focused on them or not, but when you are revising them, please go through. And again, I'll remind you, you don't need to go into look into any book, extra book or something. Follow the video, read the slides provided, and use the R codes. That will be enough. If you have queries, post them in discussion forum, post them here, or you simply drop me an email. Fine, together you can surely learn it. Very easy. Is there any question about week 1? Okay, I do not see any question on week 1, so I'll move to week 2. Linear algebra. Now, somebody in the last session here asked me why we are learning linear algebra. So nobody has asked the question here. Let me start with that question. We are learning linear algebra for two reasons. The first reason is if you look into your data, if you are doing any experiment, if you are a PhD student or research scholar, go back and check your data. You may be storing your numerical data in an Excel sheet. So you have rows and column. What are these? If you have now gone through my lectures on matrix and vector, you must be realizing those are nothing but matrix and vectors. Now, when you will use tools like R, which are not clickable, you do not click, you do write codes to access data, manipulate data, merge data. What you do is actually you work on matrices and vectors. So if you know what is vector operations, what is vector arithmetic, what is matrix operations, then these are like child's game for you. If you do not understand the matrix and vectors, right, then you will be in trouble. Because when we use some spreadsheet like SPSS, Sigma plot or Excel, we don't bother. We can select one row and I can do some operation on that and can ask give the mean of that row. Right? Very easily we can do that. But if you are using R, right, and you have a complicated script where lots of things are happening and you have to calculate the mean of one column of a large data set, you have to tell R that see this is the vector I want. Take that vector, calculate the mean. So that means you are actually doing vector operations, right? Although many times we do not call them vector and matrix, we may call it data frame or something, right? But eventually, actually they are matrices and vectors. So this is one typical thing, in a practical reason for which if you want to be a data analytic person, in biology, you want to analyze large scale data coming from genomics, proteomics, epidemiology, or ecological data, all these things, large scale data, you cannot help, but you have to learn the tricks of linear algebra. Then everything is charmed. Then everything will work very nicely, right? The other thing is that all the model, almost all the model that machine learning people use, starting from linear algebra, polynomial regression, right? Even nonlinear regression, creating nonlinear model. We will discuss all these things, right? These are very frequently used in biology. Dimension reduction, classification by, logistic regression, all these will eventually fall into, linear system, linear problem based upon linear algebra. Now, if I have to understand how these processes, how this algorithm works without going into line by line of the mathematics, if I have to understand, appreciate what they are actually doing, I need to know some bare minimum amount of linear algebra. So that's why this part we have to cover. So what you should focus on, okay? Not everything. You don't have to pick up a linear algebra book and start learning linear algebra. You don't need to join a linear algebra course on NPTEL or Coursera or somewhere else to do this linear algebra for this course, right? For basic data analysis. What you have to know? You have to know how you can represent your data as vector and matrices. Look into our lectures. We have given ample examples. Then very simple thing. You have a vector. Create a vector. How to add them? How to multiply? What is dot product? What is length? Angle between vectors, very important. Angle between vectors are very important because, for example, you have microarray data, right? So in that case, each gene can be a dot in a higher dimensional space, and you want to find which gene is close to each other. In that case, the distance between two genes sometimes is considered as the angle between two vectors representing these two genes. We'll discuss that. When we will discuss about data clustering, we'll discuss about this. But you have to know how to calculate what's the meaning of the angle between two vectors. Otherwise, you will be completely at loss. Because you have to understand at that time, should I use Euclidean distance or I will use angle distance for my data? And if you change the distance measure, your clustering will give completely different answer. So you have to understand what is meant by length of a vector. What is Euclidean distance? What is angle between two vectors? So that is why in these lectures we have discussed about angle, projection, unit vector, orthogonal vector, vectors which are independent, which make you can anyway imagine they are perpendicular to each other, right? So you have to focus on. you have to know different types of matrices, because when you will be working on R, you will manipulate these matrices, you will create these matrices from data. So you have to understand what is a square matrix, what is a rectangular matrix, identity matrix, diagonal matrix, symmetric matrix, this. And then once your data is in a matrix format, columns and rows, it's a matrix. Now you have to do some operation. You may have to transpose, means you want to convert the rows into column into rows. May have to calculate the inverse. And then comes the multiplication and eigenvalue, eigenvector. Almost every step you will go, they will calculate eigenvector and eigenvalues. And the R function, you will not do it by hand. The R function for a particular model building will throw these eigenvalues, eigenvector, but you have to understand what is the meaning of that eigenvalue, eigenvector, right? Otherwise, you will be in loss. You will not be able to understand what is the meaning of it, right? So I do not insist that you have to know to calculate eigenvalue, eigenvector by hand. Eventually, the R will do it for a particular purpose, right? But you should know what is the meaning of it. So as I have said earlier, as I have highlighted here, see, practice these issues, these techniques like determinant, transpose, all these things, multiplication using a simple system, 2 by 2 system, at least, right? So by paper and pen, and you will see it will become very easy for you, and you will be able to answer questions also. Then in this session second week also we have linear system, how to solve linear equations, right? This seems very simple. For example, you may wonder, I have solved linear equation in school also. Means even in 10th standard, you must have solved linear equations, right? Then why we are learning it in a complicated way? Because you have not solved certain type of linear equations we call overdetermined system, right? Which are actually a problem of optimization. And we will encounter them in this course. Also, the matrix-based method you have not used to solve equations. But when you will do data analysis using R, you will actually use this matrix-based method almost every day. So you have to understand that. One idea, very important, we have discussed in the video also, lectures also, is that what do you mean by independence between vector, independent vector, independent linear equation? Please always keep that in mind. Just like understanding mutually exclusive and independent events are very important. Similarly, linear independence between vectors, your variables in your data, and your equations are also very important. There is a video on SVD. I believe some of you find it very difficult to understand. Please don't get bogged down in that. I have kept SVD for advanced learners. Some of you are advanced here. So for them, I have kept it. We will not use SVD directly, but many of the algorithms that we'll use in R or MATLAB in Python, those algorithms on the background below the hood will use SVD. So I have kept that SVD thing for advanced learner. You are finding, if you are finding it bit difficult to follow, you can actually do not spend much time over it. You can just superficially go through it, right? So this is about week 1 and week 2. I have some questions on Swati Rai has asked a question I missed in YouTube about covariance. So what is the question? So Swati, you want to know what is covariance, or can you frame the question once again? What you exactly want to know about covariance? If somebody has any other question about week 1, week 2, or any other up to week 3, please post the question here. We'll discuss. Okay, there are 2 questions. One is total data analysis for biologists applications. I will go to that. I thought you people know that's why you have joined the course, but anyway, I will discuss it. So Swati, if you are not here for any other, you have to understand the covariance is nothing but you are looking into the joint variance, isn't it? So covariance is in a way, you know how to calculate it, but in general formula, it is the expectation or mean of you have 2 random variable x and y. So I take x bar and y minus y bar. So if you, this is covariance of X and Y. Whereas if you remember, the variance in general of a random variable X, what is random variable in this case? Maybe this is a measurement of gene expression of a particular gene, suppose P53, in I have 100 samples, right? So obviously in 100 samples, the expression of those that P53 will not be same. So that means I can consider the expression of P53 as a random variable and I can calculate the variance. In traditionally, what you may have in an Excel sheet, you may have rows as the patient number and the gene expression level for each gene in each column, and you can ask, okay, what is the variance and mean for each column, right? So I'm writing a generalized equation, which is much easier to understand, is that actually variance is nothing but expectation or mean of X, which is the random variable, minus X bar, the mean of that, take the square of it. You can easily see that similarity between covariance and variance here. So in case of variance, I'm talking about one variable, one random variable, right? Suppose one gene. Whereas in case of covariance, I'm talking of two random variable, two genes, X and Y. So here, for one variable, I have the square term. Whereas for the covariance, I take the one part coming from X, the other part is coming from Y. So if X and Y are same, then you can easily see this covariance will become variance, right? And if you look into the video, you will see this variance, remember, has a square, right? Something square. Something square can never be negative. It can be zero, right? It can be zero. Suppose some measurement is constant across all samples. So variance is zero. It can be zero, but it cannot be negative because it is a square thing, fine? But covariance can be negative and positive both, right? So the advantage of covariance is if the covariance is positive, then it indicates in a way, I will say insist that in a way term is important here because it does not clearly tells that what I'm going to infer right now is exactly correct, right? In a way, roughly tells me that possibly there is a positive relation between these two variables, right? Whereas if my covariance is negative, means my data is distributed like this. I have X and Y, two variables, two genes, suppose gene 1, gene 2, and my covariance is coming negative, then I can expect that, okay, there is some sort of negative linear relation between these. But without doing further test or measure other statistics calculation, you cannot actually be sure about it, right? But it grossly gives me an idea. And another important thing is that if X and Y, two measurements, suppose two genes, right? Two genes expression, if they are independent, that means expression of gene does not affect the expression of gene 2 or expression of gene 2 does not affect the expression of gene 1, then they are independent, right? So happening one does not affect the happening of the other. If they are independent, in that case, the covariance would be zero or very close to zero because your data has noise, right? But remember in the video, I have said specifically, getting covariance zero does not mean they are linearly independent. They are independent, right? This is important. The reverse is not true. If they are independent, covariance will be zero. But if the covariance is zero, that does not imply they are independent. These two things are opposite sentences, but they are not same. We have to be very careful about it, right? So many times we make in haste, we make this conclusion that, okay, I have got covariance equal to zero. Oh, that means these two are independent. No, you cannot. I have given an example of a nonlinear relation between two variables, and that also gives you covariance equal to zero. So you need other tests to check out, right? For example, we'll discuss those in upcoming videos. If Swati is still online, I hope I have cleared your doubt about covariance. Okay, tell the application of data analysis for biologists. Okay, so see, the simple thing is biology is experiment driven, primarily observation. It's an empirical science. It is not like that. You are just doing computation or you are doing analysis. You are deriving something. You people do that. Mathematical biologists and computational biologists do that, but overwhelmingly, most of the biologists are experimental biologists, empirical, right? So when we say that we have to do empirical observation, that means what? You are collecting quantitative data, right? Qualitative data we collect sometimes, but qualitative data is not good for science. Eventually, we convert them in quantitative data, right? So biology relies on data. The question is, what is the size of the data? You look into 60 years old, 60 years old paper, download them. They also have data, right? So data is, ubiquitous. Every time you are doing the experiment, you are doing data. You are collecting data, and you do not use raw data. You cannot. The raw data tells you nothing unless until you do some analysis of that. Any sort of analysis. When you calculate the mean, it is an analysis. When you visualize that as a bar plot or a scatter plot, you are doing analysis, right? Just the numbers will not tell you anything. You have to analyze them. So you are anyway doing data analysis, and biologists are doing data analysis for ages. Now then, what is this course for? Okay. Now, just beyond the mundane data analysis, there are two aspects. One is the classical, what is called biostatistics. Biostatistics allows us to compare different experiments, different between samples, different between groups. Biostatistics is based upon the basic idea that what data is telling us, may not be actually correct unless until I do some corrections, I do look deep into it, right? Data can actually fool us. So that's why you do test of hypotheses and you do other things in biostatistics, right? That is one sort of advanced levels of data analysis. We are not going into that because there are courses on data, biostatistics. What we are looking into, apart from biostatistics, data analysis has some other things. For example, model building. You have actually built model. If you have done any experiment where you are taking different concentration of known protein sample and then creating a standard curve by fitting a linear equation for Beer-Lambert law, you have actually created a linear model and you have used that linear model to calculate the concentration of an unknown protein sample. Nobody may have told you that you are creating a linear model. We create this type of linear model, non-linear model when you have large scale data. For example, you want to find a model which can use gene expression to predict hypertension, right? So in that case, it can be linear, it can be non-linear. So you create models. So we'll discuss that. So this is a part of what we call statistical learning, statistical model building, or machine learning. But machine learning or statistical learning does not stop there. Another example. Data dimension reduction. If you are doing single cell RNA-seq, if you are doing proteomics experiment, if you are collecting data for microarray, you know your dimension of your data is very large. You cannot do many visualize them. You cannot make any meaning out of it. So you pick up any good journal paper nowadays, they will have this high throughput data, and then what they do? They do all these things like dimension reduction, data clustering, all these things. So these are advanced data analysis. You are not just doing mean variance calculation or statistical test, right? So these are again part of machine learning or statistical learning. So we learn those things in this course. Now think about you have this data, you have clustered, you have done the dimension reduction, but you want to use that data to classify something, disease, non-disease, right? Something like that, which is again very common in nowadays. So then these are called classifiers. So again, these are advanced data analysis and comes into the category of statistical learning and machine learning. So that is where this course stands, right? So we learn these things. So I hope I could have answered your question. There is one question in the Teams. Let me answer that. Can you explain the problem or what is the probability Eucharistic maintain while calculating subtract 5? Okay. I don't know whether you have asked this question in the discussion forum or not. I have answered this question in the discussion forum also. Let me answer it once again here. So to answer this question, I leave the clue. Again, I have done the same thing in case of discussion forum, but again, I'll leave the clue here. If you can follow the clue, I hope it will be clear to you. Let me consider that I have 6 base cutters. That means I need a window of 6 consecutive bases, right? Okay, in place of ATGC, what I will do, I'll write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 bases, 10 base position, right? Okay, so my 6 base cutter can cut somewhere here, right? In this window. This is my first window. Maybe, I do not know, maybe, right? So I can have one window. Now let me calculate how many windows of 6 bases, 6 consecutive numbers in this case, can I get out of, if I have starting number 1 to 10, mean I have 10 bases. So I can have 2 to 7, 3 to 8, 4 to 9, 5 to 10. Can I have 6 to 10? No. 6, 7, 8, 9, 10. I have only 5. But I need 6 base cutter, right? So that means I have to stop at 5. So I can have 1 window, 2 window, 3 window, 4 window, 5 window. So that means this is 10 minus 5. Or in a way, actually 10 minus 6 minus 1. So the same principle works there. In case of that, we have 10,000 rather than 10. I hope it is clear now. Is it clear, Uma Maheshwari? Okay, good. So let me see what other questions are there. We have few minutes left. Krishna, the data set and everything are available in the, if you go to the course portal, below every lecture, something is written and a link is provided. That link takes you either to the, what we say, the PowerPoint slides, or if that lecture is about R, then it takes you to a zip folder where you can download the data and the code. There is a GitHub link I have showed initially. You will get the GitHub link also in the discussion forum. You can download all the codes and data I have used in this course from that GitHub link. Download them. Use them whatever way you want. Remember, as I said, you have to play with R. If you are learning a programming language, you have to play with it, just like a child. So you download that data set. Those data set is good enough to practice. Apart from that, remember R has some inbuilt data set. That also I have discussed in the code, right? For example, BOD data set is there in R. So in the R console, you can write, suppose I want D variable, I assign BOD. Sorry, it will be BOD. So automatically that BOD data will be loaded, right? So R has some all these inbuilt data. So it does not matter what type of data, where the data is coming from. For you, it's just number, right? You need some number of variables and the number of samples and some number, and now you play with them, right? So you can use the data that I have provided, or you can use the inbuilt data in R, right? Don't get lost in collecting data from here and there. It will waste your time. Okay, SVD, I will explain. Wait a minute, if I get time. Transition to job in clinical data management. I cannot be sure about job because job depends upon multiple things, right? Apart from you, what are the courses you have done? Also, it depends upon your proficiency and that what they are looking for. But what I can tell you, two things. One, if you want to sustain in biomedical industry in long run, you should know biostatistics and this type of data analysis. You may not eventually, use them. People under you, working under you, or if the people who are collaborating you will be using them. And believe me, there is a dearth of people who understand and able to use this data analysis tool in biology community. So if you can learn them, even as a novice, you always have an advantage, not just in clinic, but also in PhDs. If you're coming to research, many times we have students who do not know how to do data analysis. They only know how to do it using Excel. All research scholars, all the faculty, they prefer students who know how to do R, because nowadays you cannot do data analysis without R or Python. The same thing is for industry. And believe me, trust me, there is dearth of people who know both biology as well as this thing. I do not expect a biologist will become a mathematician or a computer scientist. No, that is not the goal. But if you know the basic fundamentals, if you know how to handle R, and if you have the courage to learn further, you can upfront tell your employer that, yes, I know the basics of R. That gives you edge always. It's not just the clinical data analysis anywhere. Biomedical industry require people who understand both biology as well as data and data analysis, right? So please remember that it is a general trend. I'm doing MSc. Which one should we do? Go for SAS or R? The question is not MSc or something. R is a industry standard, right? And academic standard to you in data analysis, whatever you are doing, right? So please learn it. In long run, it will help you. It will surely help you, right? Now, if you have any particular course where you have something which their course require, then you can use that. There is a question about Python and R. Before that, I'll just take another question about SVD. Without going in details, let me tell you one simple thing about SVD, which somebody has asked. I missed the name. Sorry for that. See, there is something we know that if I have a matrix A, then I may calculate in certain cases the eigenvector, which is equal to a scalar called eigenvalue into eigenvectors. Now, this V are vector. This lambda is your what we say is a eigenvalue. Now you can represent this in another way. I can create a matrix V by taking all the eigenvectors side by side, and that will become V into this lambda. These all are matrices now, right? You may have seen in the video. Now remember, this eigen decomposition can only done for square matrices, n into n. I cannot do it for a rectangular matrix. Rectangular matrix means something like this, m into n. M is suppose bigger than n. Your number of sample is much more than number of variables. Number of gene may be 4, but you have collected 100 samples. So then the data is a rectangular one, tall, skinny matrix. You cannot do eigen decomposition or any analysis where you have to do eigen decomposition of that. So when you have this type of problem, actually SVD come into help, because in SVD we can actually decompose this type of rectangular matrix into two matrices which are square. One is U, one is V transpose, and a diagonal matrix in between, which we will call sigma, right? I will not go in detail because we do not have time now, because it will take a whole data, right? Whole course class. Actually, if you see, there is a 30-minute lecture on that. So please go through that. Otherwise, you can post, if you have a specific question, please post it in the discussion forum, or you post it directly to me. Okay, now last couple of questions. What to learn? Python R, MATLAB R. It is your choice. It is your choice. If you tell me, I use R primarily to teach you this course. For the type of research work I do not generally need R. I prefer using MATLAB because I'm using MATLAB from my undergraduate days. I find it more comfortable to work. I take Python courses where students learn machine learning using Python, because there are machine learning algorithms, particularly the neural network based things, which are very good libraries in Python. That's why they use it, right? Now, there is no gold standard of what is required for what. It depends upon the type of job you do. R is good enough for the type of problem that we discussed in this course. And in fact, in some of these problems like regression, classification, dimension reduction, R functions are lightning fast and they can handle a huge amount of data. Remember, R has been written for that purpose only, for data analysis. From the ground up, it has been written like that, right? So that's why R is useful. If you want to use a neural network, deep learning, then Python may be more useful. MATLAB will not maybe much helpful for that. So it depends upon that. For this course, I will say insist, please learn R. If you are interested, and actually many of the people who want to survive in long term in data analytic industry, they actually learn multiple languages. They swap between multiple things. They sometimes use R, sometimes use Python or MATLAB or even Julia or something like that. Okay, I think we are almost 1 hour now. We have to end this session. Right. Swati, you have asked in systems biology. Systems biology is a completely different discussion, right? I will not go into this right now. Any last quick question? Last one quick question if somebody has before we say bye to each other. I may have another live session in the coming month. We'll meet. Otherwise, Pallavi will be taking every week a live session of problem solving. We are making the announcement and we have the next session in the coming Monday. Please join that. So as I do not see any more question, so thank you for joining with us today. Please join the problem solving session in coming Monday and keep learning. Keep learning. If you get a difficulty in understanding something, please post the question either in the forum or directly email to me. We will try to help you at our best. Right? Together we'll learn this course. Together we'll pass the exam with with a very good grade. Please keep your morale high and stick to the course. Thank you for joining with me today. Thank you for learning with me today. See you.
Thank you so much, sir.